So let's continue. In the following, we will show you many examples. It's kind of, we will use the Arclength formula to compute a specific example, So let's get started. So look at our first example. So the example is find the length of the arc of the semi-cubic parabola y squared is x cubic between the point 1 to 1 and the point 48. So let me draw a picture for you. If you check the textbook, it do have a picture for you to read. So this is our picture. Okay, this is 1, 1. So this is 1, 4, 4, 8. So the question is, I will illustrate on the graph, is compute the length of the arc, this part. Okay, the red part. By the formula we know, so the length is the integral. If we write y as a function yx, right, is the integral from 1 to 4. The integrand is the square root of dy1 plus dy dx and complete square and dx, right? So when you are doing a problem, I hope you can write this formula in your paperwork, because you will get a partial grade partial credit if you write this in the test. So let's first compute y. So y squared is x cubic. By the graph, we know y is greater than 0, right? So y is x 3/2. The power is 3/2. And then let's compute this, or dy dx. So this is 3/2 y. 3/2 minus y is half, right? And the squared dy dx is 9/4 y, right? So we have here is the integral from 1 to 4. The integrand is 1 plus 9/4 y. Sorry, I think I made a mistake. So okay, let me erase it. So where I made a mistake, I think you may know here. So this is x half x, right? So here is x, no y, this is x dx. So let's compute this. I think last time we talked about this, we have to rationalize the integrand, right? We use the u substitution. This is 1 plus this x, and then du is 9/4 dx. So dx is 4/9 dx, sorry, du, right? So by substitution, so we have air is the integral. So if you look at this as x equals to 1, u is 1 plus this is 13/4. As x equal to 4, u is 1 plus 9 is 10. So the bounds, now the integral bounds is 13/4, 10, and the integrand is square root of u, and dx is 4/9 du. So we get this is 4/9, the integral bound from 13 to 4 to 10, square root of u du. And then let's continue. I think this is the basic integral we have to know, right? So this is 4/9 and 2/3 u 3/2 and 13/4 10. Let's plug in this. So we get 8/27, right? 10, right? Minus this power 3. I don't think we can, anyway, if I will keep this, even you continue to simplify it, you cannot kind of do the compute calculation for this two. You cannot compute the differences. Furthermore, okay. So this is the first example, right? So I read a remark to tell you, first, when you are doing problem, I hope you can write the abstract formula first. You may say, why do you do this? Because you can get the partial credit if your computation is totally wrong. Partial credit. That's very important. Okay. The second step, you compute the derivative and then compute the complete square. Okay. Third step, plug in the y complete square into the integral. Just my experience, if you write this, you made a mistake in some steps, and I can still recognize how do you made a mistake. It helps you. I think so. And for calculate the definite, the integral. Okay, this is a hard one, right? If you can remember the formula, the Arclength formula, right? This is 1, 2, 3 is quite easy, right? The hard part is how to compute integral. But in the first 3 weeks, we already studied many tricks or techniques to compute the integral, right? Anyway, so I'll stop for this example. Okay, let me go to our second example. So, so let me do something new. So if you look at so let me what happened? Review the formula. So which is there? So we have a function y is fx or yx, right? So the formula over the interval a, b, right? So the formula of the arc length is the square root 1 plus y prime complete squared dx, right? But not always we can write y equals to a function. Oh, no. Sometimes, by our convention, we always write y is equal to yx, right? But sometimes, so let me erase the extra. Sometimes we have, x is xy. It means that x is a function in terms of y. In this case, y is between a and b. Unlike the previous case, x is between a and b. So by the same argument like before, we have the integral is from a to b and dy, because now the variable is y, right? So this is the square root 1 plus x prime complete the square, right? Same, you just exchange x with y, right? You get the formula. So let us look at an example. Sometimes I know if you look at the abstract formula, you feel it's hard. Whenever you meet a specific example, you may feel much better. It's the same for me, right? Sometimes the math is very abstract. So let me look at an example 2. So find the length of the arc of the parabola y equals to x from 0, 0 to the point 1, 1, right? So you can say, okay, we can write y as a square root of x. Yes, you can, but there is an easier way. Okay, either way is we regard x as a function of y, so this is y squared, right? And then air is the integral from a to b, right? Is 1 plus x prime complete square dy. Be careful, this is y, not x. And a, b is the range. Sorry, is a, b is between 0 and 1 and 1. You may say which 0 and which 1? You have to know now a, b stands for y, not x. Okay, this problem is kind of tricky, right? 2 point are the same, x 0, 0, 1, 1. So let me compute this, right? dx, dy, or xy. So this is 2y, right? A is 0, b is 1. So let's plug in air is 0 to 1, square root 1 plus, right? dx, dy is 4x, 4y squared. So this is 4y squared dy, right? So now let's continue to compute this. Whenever I think, in trigonometry, in a section of trigonal integral, where you're trigonal substitution, we know how to deal with this, right? So let me assume y is half tangent theta. Okay, so we know y is between 0 to 1. So tangent theta is between 0 to 2, right? I think I'm right. Okay. So let's continue to compute this. So we have dy is half secant squared d theta, right? We can know the theta is between tangent inverse function 2 and 0. Okay, let's continue to compute. So, and then 1 plus 4 complete square y squared is square root 1 plus tangent squared theta. This is secant, right? Theta. So let's use the substitution. So this is from 0 to tangent negative 2, right? Secant theta and half secant squared d theta. So this is half 0 tangent inverse alpha 2, sorry, not alpha, secant cubic d theta. So here is kind of tricky, right? So if you check the example from the previous check, the example, you check the example already computed it. So this is the example 7.2, right? We know the antiderivative of this term is half secant theta tangent theta plus ln secant theta tangent theta, right? And value is between 0 and tangent inverse theta. Okay. So anyway, you know, sorry, it's 2. You know, the computation is kind of tricky. You know, we have to know how to, you know, here is kind of hard. I think if there is a test, I will not give you the problem like this because it's too hard, I think. But you know, as a lecturer, I can show you, you know, you understand the process, you know. But in the real life, in the future, you may meet a problem which is very hard. But why I didn't give you a problem in the test because, you know, we have enough. Our test in general is 1 hour. Okay, so let's continue to compute this part here. So we have tangent, okay, and tangent inverse 2 is 2, right? We have secant theta, right, is 1 plus tangent theta squared, right? And compute this. So here we take theta is tangent inverse 2. So we get this is square root of 5. So we have this is half and half square root of 5 multiplied by 2 plus square root of 5 plus 2 minus, you know, here I think this is a half. Minus 0. And you plug in this, right? What's this? Right? 0 is 1, so dot 0. So this term is 0. And then by the, you know, simplification, we have this is square root of 5 plus ln 2 plus square root of 5 over 4. Okay, this problem is kind of, you know, the computation is kind of complicated, but it's still okay. Okay, we already, in fact, we already use this tricks many times in trigonometric substitution, or in the part of trigonometric substitution. So I think I will stop on this two example and make more video later. I'll make the recording shorter and shorter. Okay. These two examples have different styles, right? The first one, you write y as a function of x. The second one, you write as a function, you write x as a function of y. Both formula are very important. You should know both, or you should remember both. Okay. So I will stop here. Stop here. Okay. Oh, what happened? My computer always has a problem. And